mathematicians, what's up? Bella here, and today we're going to dive into graphing trigonometric functions. But first, before we start graphing, let's lay down the basics of trig functions. So in total, there are 6 trigonometric functions. The first 3 are going to be called sine, cosine, and tangent. So these represent the relationship between the sides of a right angle. So as I've drawn here, we have adjacent, hypotenuse, and opposite. And they're all related to the theta, aka the unknown angle right there. So, and this is just for right triangles. So to remember this, to remember each of the first 3 trigonometric functions, they're going to be one side over the other. How you remember this is something called SOHCAHTOA. So let's write that out. So stands for S-O over H. So that means sine is opposite over hypotenuse. Now we have C-A over H, which is cosine adjacent over hypotenuse. And then we have TOA, T-O over H, which is tangent is opposite over hypotenuse. So those are the first 3 trigonometric functions. The second 3 are going to be their inverses, which just means that you flip them. Just like if you're making an inverse fraction, that's what that's going to be. So, and they're called cosecant, secant, and cotangent. So cosecant relates to sine, secant relates to cosine, and cotangent relates to tangent. And these are just going to be their reciprocals. Awesome. So now that we've got that figured out, let's go on to graphing. So first, before we start graphing, let's remember what a basic linear graph looks like. A linear graph, let's start with y equals x. And as I talk, I'm going to put in some pictures of these graphs. So y equals x is going to be a straight diagonal line, and it's going to be going upwards. And that's just the basics of graphing. But then when you start bringing trigonometric functions in, you have to incorporate things like periods, like the amplitude, like vertical shifts and phase shifts. So how we incorporate those, let's start off with an example with a linear function. So if you have y equals x, it's just going to intersect at the 0 and go on from there and have a slope of 1. If you change the slope to 2, it's going to increase at 2 over 1. So it's really similar for trigonometric functions. Right here I've written down, I might just actually insert a picture in, but a good example to use is, so we have x and y. Y is our input, x is our input, y is our output, and then we have A, B, C, and D. So A is going to go before the trigonometric function. For instance, if you have y equals sine, it's going to be y equals A times sine. Now this A is going to be changing the amplitude. The amplitude is the height of the function from its minimum to its maximum point. So this can be changed with A. And then we have B, which multiplies the x, which is the input here. So the period is when a function goes through one full cycle. So and the formula to so when you have B multiplied by the x, which is the input, you want to put it in the formula 2 pi over B to get the period. So a basic period is going to be 2 pi, and the period is going to be split up into 4 intervals. So let's say you have y equals sine 4 times x. 4 is the b in this situation, so you are going to plug in that 4 in 2 pi over b, so 2 pi over 4, and then you get your new period. Now on to c. C is when you add to the x, aka the input, and C is going to be the phase shift. So phase shift is when there's a horizontal shift with the function, and that'll be across the y-axis. D represents the vertical shift, which is the vertical change, or as it says, vertical shift, which is, D is added to the whole rest of the equation. So let's start off graphing a really simple graph. Let's just do y equals 2 sine x. I'll give you a little bit to try and figure this out yourself, and then I'm going to pop it up on the screen. Pause if you need more time. Okay, so here's a graph of y equals 2 sine x. Here it is. If you got that right, awesome. If you didn't, look over your work. That's okay. It is really pretty easy to see the difference between a sine graph, a cosine graph, and a tangent graph, and even their reciprocals, cosecant, secant, and cotangent, because they have a very distinct pattern. So you're going to pretty much be able to tell, if you study the patterns, what type of graph this is going to be. I'll put up some pictures of the different types of graphs, and then we can go into things like their reciprocals. Also, if you need a way to organize your numbers, I recommend doing a chart to plug in the x and the y values, and then you can graph your points and not just go based on the pattern. Okay, so now I'm going to insert a picture of a cotangent graph, a cosecant graph, and a secant graph. So these are going just like I said previously. They are the reciprocals of sine, cosine, and tangent, and so they're going to basically be the opposites of them. So cotangent is basically just the same as tangent. It's just going to be going the opposite way. Cosecant is going to be it's going to have things called asymptotes, which are actually lines that are always approaching zero but never actually reach zero, and that's how they get these like parabola type shapes and type functions that are the reciprocal. So cosecant the reciprocal of sine, and secant the reciprocal of cosine. I'm going to put up a few more graphs here if you just want to check it out, and then at the end I'll put a couple of questions if you want to go and do it yourself. Hope this was helpful. Bye, mathematicians.